NASA has telescopes pointed at objects 13 billion light years away. It has rovers crawling across another planet in real time. It has a probe that has left the solar system entirely. The whole job is to look outward. So when the data coming back from those instruments starts revealing things nobody has a real explanation for, things inside our own galaxy, on our own planet, in the space between stars we thought we understood, the question stops being about how far we can see. It becomes about what we are actually looking at. Here are 8 things NASA has confirmed, tracked, and published, none of which have a clean or comfortable answer. Number 1, 95% of everything is something we cannot explain. Everything you have ever seen, every star, every galaxy, every atom in your body, every object that has ever existed in recorded history, all of it together adds up to roughly 5% of the universe. The other 95% is made of 2 things nobody has ever directly detected and nobody can explain. About 27% is dark matter. It does not emit light, absorb light, or reflect light. The only reason scientists know it exists is that it exerts gravity on things we can see. Without it, galaxies would fly apart. They do not. So something is holding them together. Decades of experiments built specifically to detect it have come back empty. The remaining 68% is dark energy. In 1998, 2 independent teams of astronomers studying exploding stars expected to find that the universe's expansion was slowing down. Gravity pulls things together, so a universe expanding since the Big Bang should be decelerating. What they found was the opposite. The universe is speeding up. Something is pushing everything apart faster and faster. That something was named dark energy. The discovery won the Nobel Prize in Physics in 2011. Nobody knows what dark energy is. It makes up 68% of all of reality, and the best description scientists have is that it is a force embedded in the fabric of space itself that keeps getting stronger as the universe gets bigger. Albert Einstein originally introduced something called a cosmological constant into his equations to account for a similar idea, then abandoned it. The current data suggests he may have been pointing at something real without knowing it. The things we actually understand make up 5% of everything. The rest is a mystery with a name and nothing else behind it. And the deeper scientists look, the more that 5% stops feeling like a foundation and starts feeling like a very small island. Number 2, there are 2 enormous gamma ray bubbles growing out of the center of our galaxy. In 2010, scientists processing data from NASA's Fermi Gamma Ray Space Telescope found something sitting at the center of the Milky Way that nobody had ever detected. 2 massive structures, one extending 25,000 light years above the galactic center and one extending 25,000 light years below it, shaped like an hourglass, both pumping out gamma radiation, the highest energy form of light that exists. From end to end, they span 50,000 light years, roughly half the diameter of the entire Milky Way. They were so large that if rotated flat into the galactic disk, they would extend past our own solar system. They had been sitting there, in the center of the galaxy our planet belongs to, completely undetected until the right instrument stripped away the fog of other emissions hiding them. The astronomer who first identified them said plainly that they did not know their nature or their origin. Scientists still do not have a definitive answer. One possibility is that they are the remnant of a massive eruption from the supermassive black hole at the galactic center, which contains the mass of 4 million suns that happened somewhere between 6 and 9 million years ago. Another is that they came from an enormous burst of star formation. The material inside the bubbles is moving outward at roughly 3 million kilometers per hour. What nobody can explain is why the structures are so perfectly symmetrical and so sharply edged on both sides. Most known processes that produce these kinds of structures do not generate that kind of geometry. The bubbles span the sky from the constellation Virgo to the constellation Grus, visible only in gamma rays, sitting directly above and below the center of the galaxy we live in. The bubbles are still expanding right now. Number 3. Earth's magnetic shield has a growing hole in it. Earth's magnetic field is the reason life exists on this planet in the form it does. It deflects charged particles from the sun and blocks radiation that would strip away the atmosphere. NASA has been tracking an anomaly in that field for decades. It is called the South Atlantic Anomaly. Over a region stretching between South America and the Southern Atlantic Ocean, Earth's magnetic field dips dramatically close to the surface, allowing charged particles to reach depths they should never reach. Satellites passing through regularly experience hardware malfunctions and computer crashes. NASA documented laptops on space shuttle flights crashing when passing through it. A Japanese X-ray observatory called Hitomi suffered a chain of events linked to the anomaly. The International Space Station passes through it on every orbit. It is getting worse. The European Space Agency's Swarm satellite constellation spent 11 years, from 2014 to 2025, measuring Earth's magnetic field. The anomaly expanded by an area nearly half the size of continental Europe in that time, while continuing to weaken in intensity. Since 2020, the weakening has accelerated, and the anomaly has split into 2 separate lobes. Scientists believe the cause is connected to strange behavior deep inside Earth's liquid outer core, where magnetic field lines that should emerge from the core are instead reversing back into it. A massive blob of unusually dense rock sitting roughly 2,900 kilometers beneath the African continent is thought to be disrupting the process that generates the field. Nobody is saying the field is collapsing. What they are saying is that it is behaving in ways that suggest the processes generating it are far more turbulent than the steady shield it appears to be from the surface. Before we move on, if you're enjoying this analysis, please consider subscribing. It helps the channel tremendously. And whatever is happening down there is happening faster now than it was 10 years ago. On September 1st, 1859, a solar flare and the coronal mass ejection that followed hit Earth. Telegraph stations caught fire. Operators were shocked by currents flowing through wires with no power connected. Auroras were visible as far south as Panama. The event was named the Carrington Event. In 1859, the most sophisticated technology on the planet was the telegraph. That is what the storm destroyed. In July 2012, a coronal mass ejection of comparable force blasted out of the sun at over 2,000 kilometers per second. It missed Earth by 9 days of orbital difference. A NASA satellite called Stereo A, positioned on the far side of the sun, was hit instead and recorded the data. Scientists who analyzed that data concluded that had it struck Earth, it would have been the most powerful geomagnetic storm in recorded history. The large-scale transformers that underpin regional power networks take 12 to 18 months to manufacture and are not stockpiled anywhere in meaningful numbers. Damage estimates from a Carrington level strike on today's infrastructure run into trillions of dollars. Restoration could take months to years. The probability of a Carrington-level event hitting Earth in any given 100-year window is estimated at around 12%. And there are rarer events called superflares observed on Sun-type stars that would release energy up to 1,000 times greater. The 2012 ejection missed. Nothing about our readiness has fundamentally changed since. Number 5. The universe is expanding at 2 different speeds and nobody can reconcile them. When scientists measure the universe's current expansion rate using nearby stars and galaxies, they get one number. When they measure it using the faint radiation left over from the Big Bang, they get a different number. Both measurements are precise. Both have been checked over and over. They disagree. The two values for what is called the Hubble constant sit at roughly 67 and 73 kilometers per second per megaparsec, depending on the method. The gap has now reached what scientists call 5 sigma statistical confidence. That means the probability that the disagreement is a random fluke is 1 in 3.5 million. It is real. In February 2024, NASA's James Webb Space Telescope and the Hubble Space Telescope jointly confirmed that the measurements on the near-universe side of this disagreement are accurate. The lead researcher, Adam Reyes, said they can rule out measurement error as the cause with very high confidence. His own description of what this means is that they need to find out if something is missing and how to connect the beginning of the universe and the present day. Two of the most powerful telescopes ever built are giving the same answer. That answer does not match what the Big Bang models predict. Either the physics of the universe works differently at different stages of its history, or there is something operating in the cosmos that has not been discovered yet. Some physicists have started using the word crisis, not informally, in published papers. Nobody has a confirmed explanation. The tension is still unresolved. 6. Something strange is happening. At the edge of the solar system, NASA launched Voyager 1 in September 1977. It is now more than 24 billion kilometers from Earth. In August 2012, it crossed the heliopause, the boundary where the sun's influence ends and interstellar space begins, becoming the first human object to reach interstellar space. Voyager 2 followed in November 2018. What the probes found when they crossed that boundary did not match the models built over decades to predict what it would look like. The structure of the outer heliosphere, the way the solar wind slows, reverses, and meets interstellar space, behave differently enough from expectations that scientists have been revising the basic description of our solar system's outer boundary ever since. Then, starting in 2020, Voyager 1's instruments detected magnetic field and plasma density anomalies, unlike anything previously recorded. The readings jumped and did not come back to baseline. Some mission scientists began questioning whether the signals were being generated by the sun at all. One theory is that Voyager 1 may have drifted through a plasma cloud expelled by a different star, which would mean the boundary between our solar system and the rest of the galaxy is more porous and complicated than any model had predicted. In November 2023, a corrupted chip caused Voyager 1 to go silent. Engineers spent 6 months working across 24 billion kilometers to fix a computer from the 1970s before science data resumed. The spacecraft is still transmitting. It is still finding things that do not match what we expected to find there. What sits beyond the edge of our solar system and what it is doing remains an open and actively contested question. 7. Galactic cosmic rays are bombarding Earth and getting more dangerous. The sun sends out radiation. Most people know that. What most people do not know is that the galaxy itself is also bombarding Earth constantly from every direction. Galactic cosmic rays are high-energy particles accelerated to near light speed by supernova explosions and violent activity around black holes scattered across the Milky Way. They stream through the galaxy uniformly and hit Earth's atmosphere in continuous showers. The atmosphere and Earth's magnetic field stop most of them before they reach the surface. The problem is, those two shields are not fixed. In the polar regions, where magnetic field lines point directly into or out of the planet rather than running parallel to the surface, the shielding effect drops to essentially zero. NASA research flights to Greenland documented this directly. measuring radiation doses at altitude in polar regions, and confirming they are significantly higher than anywhere else. Airline crews flying polar routes accumulate more radiation exposure annually than workers in many regulated nuclear facilities. NASA's own published research identifies galactic cosmic rays as the highest priority radiation hazard for human missions beyond low Earth orbit. Unlike solar radiation, which can be partially blocked by physical shielding, galactic cosmic rays carry enough energy to pass through most known materials. They break down DNA. They produce free radicals that alter cell function. They are linked to increased cancer risk, central nervous system damage, and potential cognitive effects. The sun partially suppresses galactic cosmic rays by filling the heliosphere with solar wind pressure that pushes some of them back. When solar activity drops during its low cycle, that pressure drops too, and more reach the inner solar system. With the magnetic field weakening and the heliosphere behaving unexpectedly at its outer edge, how cosmic ray exposure at Earth changes over coming decades is a question without a complete answer yet. Number 8, the biggest explosion ever recorded from our galaxy hit Earth in 2004. In December 2004, a burst of energy from a dead star 28,000 light years from Earth hit our atmosphere. The burst lasted about 0.2 seconds. In those 0.2 seconds, it released more energy than the sun emits in 250,000 years. The source was SGR 1806-20, a type of neutron star called a magnetar. A magnetar is the compressed remnant of a massive star that exploded in a supernova, leaving behind an object roughly 20 kilometers wide, but containing more mass than the sun, wrapped in a magnetic field trillions of times stronger than anything on Earth. When the crust of a magnetar cracks in what is called a starquake, it releases a burst of gamma rays and X-rays, unlike anything else in the known universe. The December 2004 event was the most energetic thing from outside the solar system ever recorded striking Earth. It measurably ionized the upper atmosphere from 28,000 light years away. Scientists have calculated that a magnetar positioned 10 light years from Earth releasing a comparable burst would likely destroy the ozone layer. There are dozens of known magnetars in the Milky Way. Their giant flare events are not predictable. The timescales on which they occur are not well understood. The 2004 event gave researchers a precise measurement of how much energy these objects can release and how far that energy carries across interstellar space. What made it particularly unsettling was that SGR 1806-20 was not considered unusually active before the event. Nothing flagged it as a threat before it fired. The burst came from 28,000 light years away and still changed Earth's atmosphere. The question of what sits closer than that and what it might do is one that physicists take seriously, and almost nobody outside that field has ever heard of. What this adds up to: the Fermi bubbles are in the data. The South Atlantic anomaly is being tracked by 3 satellites right now. The 2012 near miss is in the stereo A recordings. The Hubble tension was confirmed by 2 telescopes and published in a peer-reviewed journal in 2024. The magnetar burst of 2004 was measured by instruments across the planet. The universe is not a stable background. It is active, it is changing, and the instruments pointed at it keep returning things that do not match the models or do not have models at all. What we understand is 5% of the story. The rest of it is still out there. If this video gave you something, subscribing takes 3 seconds, and it genuinely helps us keep making content like this.